doing really good about keeping up. But the one from Thursday is still open through midnight. And Otis, I'm missing both the opener and the assignment from Thursday. It closes at midnight. Well, 11:59. No, just Monday, not Friday. Yeah, just Monday's MLK Day. And then Colton, if you're online, both of them from Thursday, and then also both of them from Friday. If you're missing the one from Friday, it should be open until 11:59 tomorrow. Dylan, both of them from Friday. Erica, both of them from Friday. Kaden, the opener from Friday, and then Sarah, the assignment from Friday. But that one is open. It should be open until 11:59 tomorrow. That's normally how I do all of that. So let me go back to what we're doing today. On the right button. We are going to do topographic maps today, or topographic, you know, the whole potato, although I've never heard it pronounced potato before. It does not matter to me which way you pronounce it. But we are talking, where's my button? My freezy thing. I'm going to explain to you what the lines mean, what certain symbols mean. There is a paper version of this. I don't know how well, if it's on paper, actually printed out, because that copier tends to make everything really dark. But we did okay. But you guys have some symbols. You have a couple different maps that are already into Canvas. I don't know if you can make them larger or not from a Google Doc to be able to see the numbers better. But if you have a hard time reading it, then I'll be able to read them off of my screen. But we're going to be taking a look at these maps, and we're going to be analyzing different things. Everything from what is the elevation at a given point, what's the maximum elevation on the top of a hill, what's the minimum elevation at the bottom of a depression, which way is a river flowing. There's certain things that map shows you depending on what's being done with these lines. For the opener, how do you think a raised elevation, which is a hill, is drawn differently from a depressed elevation? They have to have something different. They're going to look like concentric circles. They're not perfect circles, but they're going to be rings both directions. But there is something that is different on a depression's lines versus a hill or an elevated up higher in sea level. You all know what that difference is. Okay, they're Hessier lines. It almost looks like railroad tracks that goes around a depression. A hill does not have that. And I think I'm pronouncing it correctly. I didn't go back and double check the pronunciation on that, but that's how my brain pronounces that. It is spelled H-A, I want to make sure I'm spelling it right. It's on your thing. H-A-C-H-U-R-E. It's how that's spelled. Because they're going to look like bullseyes. Both a hill and a depression looks like a bullseye. Depressions have these little hash marks all over. I am hoping that this is going to be rather quick so that you guys can do this. Please do not try to do the assignment beforehand because half of it is reading a map. So just wait. I would wait because you don't know how to read these things yet. They teach topographic maps in aquatics? No. Really? No. Whoops. Let me go backwards one. That's not good. So wait, Kaden, because you get another shot at it. This shows the elevation in a particular region. That is the purpose of these types of maps. Now, some of the really nice globes put that on them. Okay, but that's for large regions. So you can see like mountain ranges. It's almost like Braille, but it's not really Braille. It's not the dots to tell you letters and numbers. But some of the globes do have elevation on them. Now, a map is going to be a much smaller section than the entire planet. And the way that they show elevation is they connect equal elevations, equal whatever it is. It's 50 feet above sea level. It's 260 feet above sea level with what are called contour lines. When we did air pressure, they were called isobars. It connected equal areas of whatever the barometric pressure was. It can show rivers or streams or creeks or brooks, whatever you want to call it, depending on how much water is being moved from point A to point B. If there are man-made structures, things like buildings, roads, railroads, schools, If there's a mine, it's like two of the pickaxe things that are crisscrossed. I don't think that one's on this particular legend. But most of these maps use the same generic symbols. You should have a legend somewhere where your map is that tells you what the individual representations mean. This is Ithaca. Okay, this particular map you guys should have on your canvas, if I'm not mistaken. We have a stream, which is this blue meandering thing, or a river, or a creek, or a brook. I guess it just ends on the amount of water. Roads. So there's a couple different roads on here. All these little squares, these are buildings. Is there a school on this one? I don't think there is. Schools have like a little flag. Oh, here's a mine. There's a mine right here. I didn't put that on the list. If you have hashed lines, those are normally trails. If it's a line that's got like hasher marks on it, which I'm not seeing, that would be a railroad. There's all different kinds of things that are being shown on this. Now, these contour lines, that's these dark lines. This one has an elevation that's listed on it as 1,060 feet. There's another one over here that's 1,080. Here's another one here that's 1,090. You need to be able to figure out the interval for your contour line. I'll show you how to figure that out. It's really not that difficult. It's the same concept as plotting points on a map. But the contour line connects an equal point of elevation. With this particular one, let's see, do they have any? Well, here's a river. Where a river crosses a contour line, you're going to see like a peak. The point, like the V, the point, is going to always point in the direction that the river is coming from. Not the way that the water's flowing. Water's flowing the opposite direction. Sometimes they have scales on them. Down here, there's 3 different types of scales. We'll talk about them in just a minute. Towards the end. If your lines are close together, you have a steep slope. It is more elevation that's being crossed in a shorter distance. If they're more spread apart, then it's a more gentle slope. So on the left-hand side, between C and D, this is a much steeper hill. And then from C to E on the right-hand side would be a lot easier to climb the hill. And there's like a topographic map, and then there's like a cross-section, a side view from the side. But the closer your lines are together, the higher you're going to go in a shorter distance. I didn't know that you guys learned these in aquatics. I could have gone a lot harder with the notes than today. Well, not everybody in here's taken aquatics, have they? Okay. Well, for the people who haven't done this, I mean, if you've done this, then this should just be a review. There might be a couple of things I covered that you haven't talked about. But for those of you who have never seen a topographic map, they need to go back to the beginning.
Here, but Olive, that's not you. That were like part of this Bible.
Were they? Yeah. There was a bunch of stuff that
We had like
yeah, they were like, it looked like the jungles and like deserts and stuff like
that was
too.
for biology.
That was for biology.
That was the brain stuff.
So that's the only subject. Well, I never taught aquatics, but I've never taught biology. I really wouldn't think I would enjoy teaching biology. The only part that, well, because it's just straight memorization, except for Punnett squares and the replication, translation, the DNA, RNA stuff. I like to have to think instead of just straight memorizing stuff. Excuse me, a contour interval is the distance between the lines. How much does that represent? Y'all, it has to be the same value. If it's 20 feet between these 2 contour lines, is going to be 20 feet to the next one. It's going to be another 20 feet to the next one. It has to be the same value or these maps don't work. Sea level is 0. I don't care if the map is being measured in meters or in feet. at the ocean, not at a lake. That's different. You can have lakes at higher elevations, but at sea level, that elevation is at 0. Now, sometimes they give you your interval on the map. In this case, it says that your interval is 40 feet between each line. You're either going up or down 40 feet in elevation, depending on which direction you're going. We're going to come back and take a look at this thing because this shows 3 different types of scales. It shows you a ratio. It shows you a bar scale. It doesn't tell you a verbal scale. A verbal scale would be like 1 centimeter equals 100 meters. This one does not have that. Now, on your Canvas assignment, when I snipped the topographic map, I cut that part off because you have to be able to calculate how much of a difference it is between the lines, like what is the interval. It's really not difficult. Hey, index lines are almost always every 5th line. When I was building these notes, it said sometimes every 4th or every 5th, but y'all, when I looked at every single map, it was every 5th line. It's either going to be darker, like bold, or it's going to be a thicker line. And what it does is it makes it easier to count. Come on, bring the map up. It makes it easier to count your distances. Because if you know how much your index is, and you've got 3 indices, I think it's plural of index, it will be 3 times whatever that value would be. Instead of having to count every single little line in between. On this one, and I think I put this on your canvas. I don't know how easy it is for you to see. So if I go and I take a look between these, so this one's 13, oh, they can't see me pointing online. There's a lot going on this map. Which one was I pointing at? This one is 1350. Okay, my next one going up that's bold, it's listed up here. Okay, but this entire contour line is at 1400. So you've got a difference of 1400 minus 1350 is a total of 50 feet. And because there's 1, 2, 3, 4, 5 lines, that means each line is worth an elevation increase or decrease of 10. It's not, you take the distance between the 2 bolts and you divide it by however many lines are in between, and that's almost always 5 on these maps. I didn't come across a single one that had 4 in between. I looked and I looked and I looked. So the spacing is okay, what is the spacing of index contours on the map? They're jumping every 50, and then knowing that there are 5 lines in between, then the contour interval is 10 feet. You have to be able to do it. It's really not that difficult. You just have to find the ones that are numbered. There's a bunch of stuff going on in this map. We have a benchmark up here, this X. A benchmark is going to give you an exact elevation. So the highest point on this hill, wherever this is 1,412 feet. Benchmarks give you exact elevation. Sometimes it's an X, sometimes it's a BM. On other things on here, we got lots of buildings, roads, we got a lake. Says there's a quarry up here. I don't see any mines. This one's a little hard to read because there's so much going on. Hills. Hills look like bullseyes. If I go back to the previous one, oh, go back. That's a hill. Now, that's more of a, what I would say, steeper than just a hill. But hills and depressions have concentric rings. If it's a hill, it is going up in elevation towards the top. If it's a depression, it is going down more towards sea level. It does not mean that it's going to sea level. It could be below sea level. But the difference between the two are these almost looks like a railroad track, Hesher line that goes all the way around it. Did I put a picture on here? This is a representation of a hill. It's not a depression too. I couldn't fit everything on one slide. I put the depression on the next slide. Now, your maximum elevation, you need to be able to calculate the range of the maximum elevation on a hill and the range of the maximum or the minimum elevation in a depression. And it's a 3-step process. It's besides dividing the interval by 5. That's the only other math you're gonna have to do today. So this represents the top part of that hill. It's not showing the entire part of it, it's just showing that upper region. Anybody still need this one? So when you see a hachured line, which are these, like I said, it looks like a railroad track that goes around it. You are going down in elevation as you're going towards the center. So that means between this one and this one, if I'm going to be out to like towards the pink part, I am going up 100 feet to get to this ring. Anything that's in pink is at least 1,200 feet or more. So then I would be going down. So this would be going down in elevation down to 1,000. This depression is going to be less than 1,000 feet. Just depends which way are you going. If it's got the hash marks as you're going towards the center, you're going down. If there aren't hash marks as you're going towards the center, you are going up. I don't think I put another one on here. No. You're going, as you're going to the middle, if there's hash marks, you're going down in elevation. Okay, if there are no hash marks, if you're going into the center, to the center of the bullseye, you're going up in elevation. Because they look the same other than those lines. Hash marks, feathers, whatever you want to call them. To me, it looks like little railroad tracks. Benchmarks.
What are these supposed to be?
What? That just means that it's a depression. Benchmarks are exact elevations. It's going to be listed next to either an X, okay, or it could say BM. This one has both of them. There's an X and there's a BM next to it, and it says that it's at 1570. You don't have to calculate the range on a benchmark. It tells you the exact elevation. However, the maximum elevation of a hill or the minimum elevation of a depression, you should be able to give me a range depending on what the interval is for your contour line. There is no guessing with the benchmark. It could be a landmark. It could be like a historic, I don't know, like when you're driving down the road and you see those little signs where it says like historic something over here. There's some kind of purpose for that being here. It may just be the highest part that's on that particular hill. There could have been a battle somewhere. It could be something special was buried there. It could be all different kinds of reasons why you would have a benchmark that's actually pinpointed. Streams. Streams do not flow in a specific cardinal direction. They flow going from high elevation to low elevation. Water will always find the lowest point, period. It may be flowing north or east or southwest, or it might have a certain direction that it's going, but what actually controls the direction of a stream is it has to be going down in elevation until finally it hits, eventually they hit the ocean. That's the end point for all rivers and streams. This, and you should have a compass, normally with a map, if you're holding it right side up is north, down is south, right is east, and left is west, because we're putting it on a two-dimensional paper. This stream up here is 5,800, I'm assuming feet. Down here is 5,600 feet. It is going in the direction that the elevation is going down. In this case, it happens to be flowing south. The V, literally the V, this, it looks like it's making a V. It points in the direction that the stream is coming from, not the direction that the stream is flowing. I know the previous district that I was at, the lady that gave me a bunch of the ESS stuff that I've been using, that was one of the things that people were constantly getting backwards, was the direction that the stream is flowing. It's not flowing in the direction of the V, that's where it's coming from. The streams flow the other way. The whole upstream and downstream. Upstream would be the direction of the V. Downstream would be the direction of the way that it's not pointing. Like I said, in this case, this stream is flowing south. Here's like, I don't know if you guys calculated this in aquatics or not. If you have a hill, that bullseye, that very center ring, you should be able to tell me a range that whatever the apex of that hill could fall into. So the first thing you do is you count your contour lines, whatever your interval is, 10 feet, 20 meters, 100 feet, whatever the difference is. And you're going to pretend that there is one more circle up there, one more line, even though there's not. And then you subtract 1 from it. So let's say that the contour interval is 10 feet. And let's say the lines is, let's say it's 70, 80, 90. Then 1 more would be 100. Subtract 1, the maximum elevation of that hill would be between 91 and 99 feet. So when I do ask you to do this on the test or on the assignments, you should be able to, knowing what that range is, take a look at my answer choices and be able to pick the answer choice that falls within that range. Figure out your interval, whatever the high point is, pretend there's 1 more, and subtract 1. And that is the maximum value for the height of that hill. Very similar to do it for a depression. Okay. Oh, this is showing you what I mean. So this one, 10, 20, 30, 40, 1 more would be 50. Subtract 1, the maximum elevation of this bullseye, this target in the middle, would be 49. I'm assuming feet, but it doesn't tell me if it's feet or meters on here. We normally use feet on our topographic maps. If you go to Europe, it's going to be in meters because they don't use the standard system like we do. To do a depression, you start off the same way. You're counting down in elevation. Make sure you're going down in elevation. Pretend there's 1 more. But instead of subtracting 1, you add 1 to it. You do need to pay attention if you are going below sea level. You're going below sea level. After 0, it's -10, -20. If you added 1 to that, let's say that was the extra bit, then it would be -19, would be the maximum depression, the maximum elevation inside, or minimum, excuse me, for a depression, the minimum inside that depression. Now, if you're already above sea level, you don't have to worry about doing the negative stuff. Just understand in a depression, you're going down in elevation, you're not going up in elevation. Scales. There are, yeah, we're going to finish early on this. I really wish I had foam paper to let you guys build some of these. I just don't. There are 3 major types of scales on a map. It could be, like this says, verbal, 1 inch equals 20 miles. Centimeter equals 100 meters. It could literally tell you, if you measure it with a ruler, this is what it translates into. It could be a bar scale, which is this one down here on the bottom. So if this is a mile and there's 10 bits, each of these would be a tenth, and you can use a ruler and then you can compare it to your scale. You could have a ratio. This means if I measure 1 inch, it means 24,000 inches. It is a 1 to 24,000 ratio. Sometimes they put both the metric and the standard on there. In fact, most of them do. But these are the 3 major types of scales. The last thing that we're going to do is we're going to analyze a topographic map, because half of your assignment is analyzing the same map for different things. So verbal scale, it literally tells you if you measure this distance, it translates to this. The bar scale, you would measure it out and then compare it to what's actually on the inside the legend, wherever that legend is. Or it could be a ratio. If you measure a certain value, how much do you upscale it by? And in this case, like I said, the ratio scale is 1 to 24,000 on this one. Okay, this is where we actually have application. Elm Brook. Let's see, here's Elm Brook, right here. Which way does it flow? No. Comes from the northeast. It's flowing southwest. That's, like I said, that is the thing that people get backwards. That I remember Miss May like banging, like wanting to bang her head against the wall is the direction of the flow. The V, so this, okay, and up here, that's pointing the way that the river's coming from. It's going in the direction that it's not pointing at. Contour interval. What is the contour interval on this map? Let's see. Let's take a look right here. I've got 100. I've got 1, 2, 3, 4, 5 going up to 200. So 100 divided by 5 is how much for each one? 20. 100 divided by 5 is 20. Each line represents an increase or a decrease of 20 feet. No. Yes, this is in miles, so it's feet. If this would have said, go away, black bar. If this down here would have said kilometers instead of miles, then it would have been meters, because you keep the same, whether you're in metric or you're in standard. What would the elevation range be for the triangulation point on Rock Hill? Where's that at? Here we go, triangulation point on Rock Hill. So remember, each one is worth 20. So I've got 100, 120, 140. Next would be 160. One less than that would be 159. So anywhere from 141 to 159 would be the maximum elevation range for, because it doesn't tell me, it's not a benchmark. It doesn't tell me specifically what the height is, but I know it would have to be somewhere in that range. Which side of Center Hill has the steepest slope? Or Center Hill? Here's Center Hill right here. We've got north, south, east, west. Where are the lines the closest together? Which direction? South. So the southern face of Center Hill would be the steepest. What is the approximate elevation inside the depression? Don't see the depression. Depression's right here. Remember, everything is worth 20. So I'm going down. This is 20. I am now at 0, which is sea level. One more is going to be negative 20 or 20 feet below sea level. You're going to add 1. So it's going to be anywhere between at sea level down to 19 feet below sea level. Honestly, that's probably the hardest part, is figuring out the range. Other little things that are on here, like I said, here's a school. We've got a railroad. This is how we represent a mine. Is there a benchmark on here? There's a benchmark here, but it doesn't tell me. Well, that might just be the letter X. That might not be. Yeah, that's not a benchmark. Yeah, the X, Y, B. That's just a letter. So. No, Hayden. I swear. All right, now, honestly, that's all I have today. Let me go look online real quick. There's no reason why you should not be able to do the 1 through 5 if you had not.
I just missed that.
Or, we get the quizzes, I know. Let me check my online students again. Where's my attendance at? Yeah, but hold on, I gotta pull this up. I don't know where to tell you to go because I think they shut you back down again. Yeah, either A-Hall or I don't know. I don't know what's going on. I don't know if kids are fighting in the bathroom, vaping in the bathroom. I don't know. But they're doing something.
I'm on my period.
Kaden,